Okay guys, now welcome to another lesson. So in this lesson we'll be looking at the atomic structure of an atom, which is a subtopic of introduction to chemistry. Okay, so right now I'm just going to begin by explaining the basics. Then I'm also going to dive into the three types of questions that they like asking on this subtopic. Those are the only things that you need to know. And like I always do, I want to focus on the questions that they ask on these subtopics. I know if you try to study from these big books like Zonda and Raymond, you might end up studying a lot of irrelevant stuff, but I'm just going to filter out what is necessary and that they might bring questions on. Okay, so now for learning purposes, I'll begin by introducing the fundamentals, the fundamental basics, so that everything will make sense. Okay, so as you can see, this update to there, the atomic structure. So it's basically the structure of an atom. And according to the scientists, an atom is somehow spherical, so meaning that it looks like this. An atom, I know the shape is not going to be very perfect, but it is somehow going to look spherical, so something like this. Okay, so you need to know that an atom, it has a center. It has a center that is made up of two particles. Okay, so it has a center that looks like this. Okay, so here at the center, there is two types of particles that are found here. So now these two types of particles are found inside. Okay, let's say this is one type and the other one is the second type. So now here at the center, these particles are contained or wrapped in a structure called the nucleus. Okay, so this is called the nucleus, written like this. Okay, so now the nucleus is what contains or wraps these two types of particles that are found inside A. Okay, so now what are these particles? These particles includes the protons and the neutrons. Okay, so the nucleus of an atom is made up of two types of particles, which includes the protons and the neutrons. Written like this, neutrons. Okay, so the nucleus is made up of two particles, the protons and the neutrons. Apart from that, there are some other particles which are also found inside this atom in the space that is left here, and these particles are called the electrons. Okay, I'll just draw them like this for some purposes. Okay, so the atoms, they are a bit scattered like this. So now one thing that you should know is that the atoms, the electrons are negatively charged. Okay, first of all, let me even label them. I'll say electrons. The electrons are negatively charged. Okay, and the protons are positively charged. The neutrons doesn't have any charge. Okay, they are not charged. So this means that here at the center we have positively charged, then around the center there are electrons which are surrounded. Okay, so now for an atom and that hasn't lost any electron, and one thing that you should know is that the electrons are the ones that moves. They are the ones that can either be lost or gained. Okay, because they are mobile, unlike the protons that are found here inside. They don't move, they don't change. Protons are always the same. even if an electron has lost or gained even if an atom has lost or gained an electron, the protons don't change. Okay. So now, for the fact that what surrounds the positive protons are negatively charged, a force of attraction is created between the electrons and the protons, and that force of attraction is what makes the electrons to be around this nucleus that we have here. It is what makes the electrons to be pulled towards the nucleus. It is because of the presence of the protons inside the nucleus. So it is what maintains them inside the atom. Okay. So it is like this. Every atom, it has a certain proton that is attaching it. It's creating a force of attraction with it. Okay. So every that is for the atom that hasn't lost any electron. Okay. So what I'm trying to say is that if an atom hasn't lost any electron, it means that the number of protons and electrons are the same, and that kind of atom is what we call a neutral atom. Okay. So when the atom is neutral, it means that it hasn't lost any electrons. Okay. And if it hasn't lost or gained any electrons, it will mean that the number of protons and electrons will be the same. Okay, you need to know this. It is very important to be applying it when answering some questions. And another concept, I think the last concept on the introductory part, is the concept of the nuclide. There is what is called a nuclide, written like this. Okay, so what is a nuclide? So now, before I proceed with explaining the nuclide, I also want you to know one more thing. One more thing that you should know is that the total number of protons that are found inside an atom is what is called the atomic number. Okay, written like this. Like this, atomic number. Okay, atomic number is represented by the letter Z. Okay, so now having mentioned that the nucleus is made up of protons and neutrons, you should also know that when we add the total number of protons and neutrons that are found here at the center, at the core center here in the nucleus, when we add them, we are going to get what is called the mass number. Okay, the mass number written like this. The mass number. Okay, and the mass number is represented by the symbol A. So you need to know these two. You will be using them throughout when you start answering the questions. Okay, the mass number is the sum of the protons and the neutrons. Sometimes they might ask you maybe to find the mass number given the number of protons and neutrons, and you're just going to add them. Okay. I just want everything to make sense when you start answering the questions. That's why every time I'm teaching, I begin by explaining the basics that are applied when you're answering the questions. Okay, so now let's talk about the nuclide. So what is the nuclide? So sometimes I might even ask you to define it. So a nuclide, it is basically a symbolic representation of an atom or element that shows the atomic number and the mass number. Okay, or if you want, you can say that shows the atomic number as the subscript and the mass number as the superscript. Now here's what I mean. So I said that it is a symbolic, right? It is just a symbol that represents an element. Okay, let's say maybe let's take an element like hydrogen, a very famous element. We have hydrogen. So now hydrogen, we know that hydrogen has got the mass number of 1.01, right? Okay, here at the top is what I was calling the superscript. Script is on the top part, and then the subscript written like this. Um, subscript, and superscript. Okay, so now the superscript, you put the mass number, then here at the subscript, sub is below. Okay, you just need to be remembering them like that. So now here below you have to put the number, the atomic number, or the number of protons. So here you put the number of protons. So by just doing this, it will mean that you have shown the nuclide of an element. A question actually comes, they might, I remember it came, they asked to define the nuclide and also to show the nuclide of the element. I've just forgotten the element which they asked, so that's why I'm explaining right now, because they might ask you. This is all you need to know, and I think let us dive into questions. Okay, so now here is the question. So the question is saying that find the number of protons, neutrons, and electrons of the following. We have hydrogen, we have carbon 14, this is actually an isotope, and we have the one that has been ionized, the hydrogen that has gained one electron. Okay, so these are the three types of questions that they bring. It's either they give you this or the remaining two. Okay, yeah, there's a case where they give the one that has been, it might have a positive or negative, or the isotope, or maybe the one that is just neutral. Okay, so now just a quick reminder. Remember, I mentioned to say that the mass number A is found as a result of adding the atomic number, which is Z, the proton number, plus the number of neutrons, right? Let me just use N to represent the neutrons. Okay, so you'll be using this formula throughout. Okay, so what you'll be doing is that in a case where you have the mass number and you're looking for the neutrons, you're just going to make this the subjective formula. So you're going to say N is equal to A minus Z. Okay, and then in a case where you're looking for the proton numbers or the atomic numbers, you're just going to make this the subjective formula, and you're going to have Z being equal to the mass number minus the neutron number. Okay, so these are the formulas that you'll be using throughout. But if you want, you don't even have to be using this. You can just answer them directly. Okay, so now let us solve the first one. Let me say solution. I say solution. So let's solve the first one. So now we have hydrogen having the mass number of 1.01. Okay, and here at the subscript we are having the proton number which is 1. So this is neutral. So now let's proceed. So the proton number is just 1. So we are going to say proton number is 1. Okay, 1 proton, because protons are always the same. They don't change. Remember, I explained that they don't change. Only electrons change. Whether it has lost or gained an electron, the proton number and the mass number, the neutron number, they won't change. Okay, they don't change. Okay, so now let us proceed, and then let's find the neutrons. Let me just here it's a U. Okay, so now the neutrons. So now the neutrons, as you can see here, you are going to subtract the mass number, which is A, minus the atomic number, that is A, or the number of protons. Or in simple terms, to find the neutrons, you just subtract this minus this. Okay, so you're going to say that to find the neutrons, you're simply going to say 1.01 minus 1, and you're going to end up with 0.01. Okay, but this is just an example, but let's see if there was 22 here, you would have just done 24 minus with whatever the mass number of the atom that you're dealing with. We're going to look at the example for the carbon 4. You say, are you under that? Okay, so this would be your neutrons. In the case maybe where it was written like this. But just know that the key concept is to subtract this from this, okay? And then the number of electrons. So now, as you can see, hydrogen hasn't lost any electron, meaning that it is neutral. And I say that if an element is neutral, the number of protons and neutrons are equal. So now here we are going to say electrons will still be equal to 1. Okay, so like this. So now let us solve the second question. So we have carbon 4. This is an isotope. The number that they put here, you need to know that it represents the mass number. So now this can also be written like this. So we already know the mass number of the element that we're dealing with. So now what we're going to do here is that we are going to go on your periodic table and check at what number is carbon at. What's the proton or the number of electrons of carbon? Because in our case it is neutral, it hasn't lost any electron. Okay, so here we're simply going to have 6. It has 6 electrons. Okay, so now you can even proceed with 7. So for protons, we are going to have 6, and then the neutrons. For the neutrons, we are going to subtract 14 minus 6. So for the neutrons, we are going to have 14. We are going to have 8. When you subtract this from this, we are going to get 8. Okay, so the number of neutrons, we are going to get 8. And then for the number of electrons, it is neutral, so we're going to get back the 6. So we're going to have 6 here. Okay, so now let us solve the last one. This one might be a very tricky one. So now let's solve it. So what do we have there? We have hydrogen. We have hydrogen with a negative A, and we have 1.01 and 1A. Okay, so this negative, it is saying that it has gained one more electron. First of all, let's proceed. So let's write its protons. So for the protons, we're just going to have 1. The protons don't change. Don't ever make a mistake of confusing yourself that no, since it has gained one more, and it means that I'm going to increase 1 to the number of protons. No, just maintain the one that is here. Okay, so we're going to say 1, and then let us write the neutrons. For the neutrons, so now for the neutrons, you're going to subtract 1 minus 1. You're going to get 0.01. As I said, even them, they aren't affected because they don't depend on the electrons. The electrons are just on their own. They are not wrapped in the same structure, and that's one of the reasons. So now let us look at the last one, the electrons. So now, as you can see, it has gained one more electron. So that this means that you're going to get the initial one plus the number of electrons that are gained. If there was like a 2 here, you would have added 2 to the initial ones. So initially we had 1 electron, then it gained one more, so we're going to have 2 electrons. Okay, so these are the only important concepts that you need to know, and that's why I've put them together in this video like I always do. so that you don't have to study different materials. Because for me to come to know these questions that they only bring, I had to go through a lot of documents, I had to study different materials, different question papers, but I've decided to put them into one video. Okay. Especially here, you don't need to get this. I mean, you don't need to get the mass that is on the periodic table. No, you have to get the one that is here when you're given an isotope. Yes, that's where I used to find myself getting confused. Yeah, and I don't want you to be confused. So you need to know that if you're given an isotope, ignore that mass number on the periodic table. Get the one that they have put on this side. That's what. Remember, an isotope is basically a type of types of element. The types of element that are having different mass numbers but same atomic numbers. So the atomic number still remains the same as the one that is on the periodic table, and the mass number will be different, and it is the one that we are given here. Okay. So this is it for this video, and I hope that you have enjoyed, and I'm pretty sure by this time you are confident enough to answer some past paper and probably tutorial questions. And make sure that you subscribe to the channel, and for more video lessons like this, make sure that you join my tutorial program, where you have access to more videos like this. And this lesson is just a portion of the lessons under the introduction to chemistry. And once you join my tutorial group, you have access to all the lessons, including courses like math, physics, and chemistry, including biology. You're going to have access to the videos. And for more videos like this, make sure you subscribe to the YouTube channel. I'll be dropping more simplified videos like this, where I expose you to all the types of questions that they bring on the test and exam to make you very confident. And to join my tutorial program, you can contact me on this number. I will add you, then you're going to have access to the lessons of the courses. Don't forget to subscribe, and I hope you have a very nice day.